Thanks a lot for the introduction, and hello also from my side. And welcome to my presentation about our project called SALCOS, Salzgitter Low CO2 Steelmaking, which is an innovative low CO2 steelmaking based on hydrogen. My name is Redenius, and I'm employee of Salzgitter Mannesmann Forschung, as was mentioned before, and here I'm responsible for the SALCOS technology development. Let's give you a small, brief overview about the presentation. I will start with a short introduction of the Salzgitter Group, that you get a better feedback and background information regarding our company. Then I will explain the background of our project, some technical issues, what we want to do in the future, and what are the plans. And I will conclude with the existing activities regarding hydrogen, which we already do here in Salzgitter, and also about the situation in the future regarding connections and so on. But let's start with a short introduction to Salzgitter Group. Salzgitter, as the name said, is a town in Lower Saxony in the northern part of Germany, and we are operating here on 5 million ton crude steel capacity steel mill, an integrated steel mill based on coal in the past, and we are the second biggest steel producer in Germany. But next to the steel activities, we are also active in the technology area, special equipment for filling machines, for example, and of course we have some worldwide located trading activities for our steel products, for example. The four business units. Today I stay here for the steel production unit, where the integrated iron and steel works is part of, and we're also operating an electric arc furnace production location nearby for mainly construction steel products. The other unit is about steel processing. It's about our tube and pipeline activities. For example, Europipe is part of the group, and also in different dimensions, the pipeline and tube production, which are already used for hydrogen. The third column is about our trading activities, and the fourth column about technology, which is filling equipment, where I think we are the second biggest machine company in this area, and we have some special machines for shoemaking and elastomer production. Why do we think that steel is so important that we must be part of the energy transformation? I think everybody knows steel is everywhere. If we have a look around here, we have some constructions made of steel. Of course, the chairs have a steel part, and also in our living at home, we have washing machines, white goods as we call them. A lot of things are made of steel in industry, for construction, for mobility, and also in our home life. So it's today already a very sustainable material which can be recycled very well. So roughly 100% recycling rate can be achieved. But as you can see in the middle of the slide, we are very energy intensive, and the iron and steel industry stands for roughly 7% of the German CO2 emissions. And we, as the second biggest steel producer, stand for roughly 1%, with 8 million tons of CO2, roughly 1% of the German CO2 emissions. And therefore, of course, we have to do something, and we will do something. And this I will present you in the next minutes. And of course, if you have a look at the renewables, also renewables wouldn't be working without steel. Just one example, a wind turbine tower construction, and of course also for PV or hydroelectric renewable energy, you need steel. It's part, I think, of mostly everything. In 2022, we start with a new strategy. We have two main objectives. On the one side, pioneering for circular solutions. And as I've mentioned, steel is a very good example of a very sustainable and circular-handed material. We will increase our activities in this direction, and we also have not just a look at steel, also at the byproduct, because it's getting all the connection of everything is getting more and more important. Also, if you look to other systems. And on the other hand, partnering for transformation, I think every company, it's very hard to do this transformation at the moment, and so you need strong partners, and therefore we have established a strong partnership within the next 2 years with different companies from the energy sector, from the construction side, who builds machines for our production facilities, but of course also for our suppliers to get the needed iron ore, to get the electricity and energy, as I mentioned, and of course also from customer side. We will produce in the future the same product as today, but with lower CO2 emissions, and therefore, of course, we have to put it and do it together in this competitive situation. The strategy is to make it more concrete. We have built some measures which we want to achieve till 2030, and one of these measures is a CO2 reduction target. So we are talking about minus 30% compared to the actual CO2 emissions, which stand for roughly 2.5 to 3 million tons, which we want already achieve before 2030. And therefore, of course, which I will explain you later, the Salzgitter project is a big part of this efforts. And in addition, we also want to increase our activities regarding scrap. So in our understanding, scrap gets more and more important, and therefore we also want to increase the activities there, also to have the possibility to use, if the customer specify it in this way, to use a higher share of scrap if possible. And of course, the transformation just makes sense when we use renewable electricity or renewable energy. At the moment, we are using coal, roughly 2.5 million tons of coal, and in the future, of course, we have to use renewable energy. It don't make sense, for example, to use coal-based electricity. To get a bit more technical, just a short introduction to the today steelmaking route. So we have two types of steelmaking at the moment: the primary steel production based on iron ore, and the secondary steel production based on scrap. And in Salzgitter, we are primary steel producers, and already in the primary steel production route, we use scrap, but we are limited to 20% of scrap. The steel production is made in a blast furnace process, so we use iron ore, something like iron oxide. So we have to put the oxide from the iron, and therefore we use carbon. And the reaction from carbon with the oxide from the iron oxide is CO2, which is sent in Germany in Salzgitter for this 8 million tons. And the product of the blast furnace is pig iron, which then come in a basic oxygen converter process, and then is processed to get steel. In the new production, which you can see in the lower part of the picture, we are thinking, or we are building at the moment a direct reduction plant. And the advantage of the direct reduction plant is that you have the possibility to use gas instead of coal as a reduction agent. And from us choosing technology, you have the possibility to use flexible shares of hydrogen and natural gas. So we will start from 2026 on with natural gas, and will then increase in the future. And of course, if we have the availability of hydrogen, we will increase the share of hydrogen. And of course, if we have a higher share of hydrogen, we will have lower CO2 emissions, because if the hydrogen gets the connection with the oxygen from iron oxide, we will get water instead of CO2. And then as the next step after this direct reduction plant, because the direct reduction plant produces direct reduced iron, it has to be melted using electricity, and this will be done in an electric arc furnace. And there you have also the flexibility to use higher shares of scrap. The route from the basic oxygen furnace was limited to 20%, and in the electric arc furnace, you have the possibility to use up to 100% scrap and 100% of DRI, direct-reduced iron. And then you get the same product. We use the same existing facilities to roll the material, to produce flat steel, to have some finishing treatments, and to get the product as it's produced today. We have a stepwise transformation process developed. So at the moment, we are operating 3 blast furnaces in Salzgitter with this roughly 5 or 4.7 million tons of crude steel capacity. And as a first stage, which will be in start operation in the mid of 2026, so within the next 2.5 years roughly, we will operate an electrolyzer with 100 megawatts, and direct reduction plant and electric arc furnace. This 100 megawatt stands for roughly 5% of the needed hydrogen. So you will see we are a future high hydrogen demander in Germany, I think one of the biggest in the future. And with the flexibility that we can use different shares if hydrogen is available or not. The second stage, which should be done before 2030, where we would shut down the next blast furnace, would be a second electric arc furnace and a second direct reduction plant. And as a final stage, we would shut down the whole conventional steelmaking route and just produce primary steel based on these facilities, on the direct reduction plant, on the electric arc furnace, in addition with electrolyzer. But of course, if we really want to use higher shares of hydrogen, we need a connection to the hydrogen network, which is very important to really transport the huge amount of hydrogen which is needed to Salzgitter. We are already, as I've mentioned, we are already in the construction phase. So the decision was made 2022 that we want to invest roughly 2.5 billion euros. We was funded by the BMWK and the lower state of Saxony with 1 billion euros. And we are now in the construction phase. So we started roughly 1 year ago. You can see the construction fields. I can't show you, but of course we have to put the new facilities next to the existing ones, that we get really a good connection and to good logistic flows of the new process steps. And as you can see here in this animation, there was the electric arc furnace near the existing steel mill. The big tower is a direct reduction plant with 140 meters in height. And this is also located really in the heart of the steel making facilities, that we get a really efficient and optimized production route. We are already very active in the hydrogen field. So we have started 2016 with a high temperature electrolyzer project with Sunfire, which has a follow-up project 2019, Green High 2, which was till, I think, September last year, the biggest high-temperature electrolyzer worldwide. And we achieved an electrical efficiency of over 80% by the usage of waste heat as an energy carrier. We already are operating a PEM electrolyzer system with roughly 4 megawatt capacity to produce hydrogen, which we already need for our annealing process. But of course, if you compare the numbers, this is something roughly 4 megawatt, and the need which we will have in the future, we are talking about 150,000 tons, which will be need just for the operation of one direct reduction plant. And so we have a lot of experience and learnings from these both projects, but of course, we need a connection to really get higher amounts for the future. And as a third building block is our Mydral. It's a small direct reduction plant where we already can operate in a small scale, 100 kilogram per hour, the process, and get experience with the usage of hydrogen and with different iron ore carriers. I think I skip the next one and come to my conclusion. So I think we are some of the pioneers regarding low CO2 steelmaking in Germany. We are already in the construction phase. Really, it's really done here at Salzgitter. We will be one of the biggest hydrogen consumers in the future. We can use the hydrogen very efficient, which is, I think, also very important. Also, if you compare to other sectors, you have a very high CO2 reduction per ton of hydrogen. And of course, what's also very important in my understanding, we are very flexible, so we can really have a look at the availability of hydrogen and then can use it very efficient manner. Okay, to come to an end, of course, we was funded. We was the first hydrogen project in Germany, which gets the notification from Brussels, October 22, and now we are doing. So, thanks for your attendance.
Yes, thank you to you, Alexander, for a very interesting presentation. Obviously, there are many questions. So the first one, or the two questions that raised most of the interest here are basically on the business case. So are you able to elaborate on that a bit? So what is the business case behind the decarbonization measures? Can you increase steel prices or other benefits? And there's also, if you look here now at the third question, the business case for hydrogen DRI, because natural gas already provides significant emission savings at a fraction of the cost per megawatt hour. So all in all, question on the business case here for your solution.
Yes, I've mentioned before, so business case, of course, is very hard. I think we are now in this pioneer role, so we started. Of course, we have some customers talking about the low CO2 steel, and it's getting also for them more and more important. If you have a look at the regulations, they also have to think about the Scope 3 emissions of them, so of the products they use in their products, for example. But of course, the product is the same. You cannot measure the difference directly. That's not a physical property, so there must be something like a classification system that the steel, the greener produced steel, has a higher value for them. And of course, it's hard to implement, but I think we need something like this for this type of industry, for this energy intensive industry, because otherwise it's not possible to difference with maybe products outside Europe. And of course, it will take some time to get it, but I think we have now the demand side is building up, and we could use it. But of course, if we have really the operational possibilities and have really an economic operation, it's hard to say now.
Okay. I mean, business is also about competition. What are your competitors doing? I mean, do you get an advantage there from what you're planning?
I think in Germany we have 4 bigger locations of steel production, primary steel production routes, and I think they follow our way. So we was, I think, the first ones starting with the transformation, and I think we are at the moment at the first position regarding the construction and the plant going of operation. But of course, if you have a look outside Germany and outside Europe, it's getting harder. And of course, there's topics like CBAM or something like this. You have to talk about it, but it's of course very, very difficult in the future because also there are some activities, but I don't know if it's really the velocity is quite the same. Right?
Okay. I mean, you talk about other countries. Are there countries that are considered role models in green steel production?
Of course, there are some countries, maybe if you have a look at Scandinavia, for example, there are iron ore, there are renewable energy, water power. So, of course, there were some activities planned. There were some existing facilities, but also a lot of greenfield plants. And but of course, they don't have the experience of the production, and of course, they are mostly greenfield installations. And it's hard to say if they really can fulfill this building up of such a plant.
Okay, and then we have time for one last question. Do you expect a degradation of steel quality with DRI?
No, we don't think so, no.
Okay, good. Thank you very much, Alexander, for the interesting
Thanks a lot.
presentation. And as usual, if you have further ones, connect with him.